Okay, and just a couple of little bits to finish up. All right. What I want to do is transportation. You can do a little subheading under your keywords from earlier. Okay. And then place each of the following sentences in order so you have a concise description of longshore drift in your notes. So there's 1, 2, 3, 4, 5 sentences. Okay, they're in the incorrect order. Have a little read through and see if you can get them into the right order. Okay, this is just a little bit more straightforward than the bonnet explanation. Okay, that's the correct answer there. Okay, so longshore drift begins with wave action. These waves must be approaching the coast at an angle. The swash of a breaking wave breaks onto the beach, moving sediment up the beach again at an angle. After the swash, there's always backwash. The backwash carrying the sediment always takes the easiest route back down the beach, using the least energy, which is usually a straight line back to the sea. Again, we're still carrying sediment here, okay? The waves approach the coast again at an angle, not an angle, and the process continues. Over time, the sediment is moved along the coast in a zigzag pattern until at a later point it is deposited or dropped. Deposited means dropped. Okay, and that deposition then, that depositing of material, which was broken away from the caves and the arches and the headlands, that will eventually be dropped somewhere else, and it actually makes new land. So while erosion breaks up the coast, deposition creates new coast. All right. What we're going to do, we're just going to jump into Bahamian landscapes. There's 3 or 4 pages to run through. It's mainly to look at some more diagrams. Okay. I found this kind of nice picture of, just to try and explain again, if this is low tide, high tide would be here at the bottom of this area. So this stack, okay, not all stacks are big towers, and very few in the Bahamas are towers because we don't have any high cliffs, okay? But you can see eventually this will get eroded away, and this whole thing will fall into the sea. All right, so on to Bahamian landscapes. Okay, so page 96, as you can see. All right, caves. I put sea caves. Just put sea in front of the word caves. Again, I've got the pages of Bonnet and New Wider World. Now, there's not too much to run through here. We're mainly using Bahamian landscapes to look at Bahamian examples. All right, coasts are coasts everywhere. The only factors that change are the strength of the waves, the depth of the water, and the geology of the coast. Okay, but usually the same features or landforms are created everywhere. So properly the term is sea caves. Okay, exhumed keys have some superb examples of different caves. Okay, there's ones used in James Bond and everything. So you can put down Exuma as one of our first examples of where sea caves are. Okay, on to the next page, page 97. Okay, caves have temporary existence and will eventually collapse. So remember, the caves, every minute of every day, those caves by the sea are getting pounded and pounded by waves. They're getting larger, the roof is getting weaker, and so on. Early indications of this collapse is a blowhole, all right, a hole in the roof caused by the pressure of waves breaking into the cave, hydraulic action. So again, the waves are free out in the ocean. When they're confined or pushed into a small cave, they become more explosive, okay, and they blast against the roof and the sides of the cave. So a blowhole is the first sign that the whole roof of the cave is about to collapse. All right. Preacher's Cave in North Eleuthera is a good example, showing many features including blowholes. So again, Preacher's Cave are a very good example. For those who do GGYA, we go there. Sea arches then. When a cave erodes right through a headland or any narrow piece of land, an arch is said to form. The glass window of Eleuthera was the most famous example, but it was destroyed over nearly 100 years ago by a hurricane. Okay, so again, sea arches do exist, and some big examples did exist in the Bahamas. Next page. So you can see an example of a cave here in Eleuthera. Again, I want to bring your attention to where the ocean is and where the cave is. Okay, so I would assume we're kind of at low tide. High tide will be at least to the floor of the cave. Okay, high tide will be at least coming out about here. And what you have to remember is it won't go the whole way to the roof, very rarely. Okay, but as the waves shoot in here, okay, they bounce around in the cave and come back out, and they essentially scoop out the rock over time. All right, you can actually see the large big chunks in here which have obviously fallen from the roof. Okay, so they'll be broken down and taken away eventually as well. All right, so some really good examples, some cool examples around the Bahamas. Stacks and stumps then, again I've got the pages of the other textbooks. When a part of a headland becomes detached, all right, such as by the collapse of an archway, the detached part is known as a stack. Okay, it's a big stack left out in the sea. This is in turn eroded so that it is awash at high tide. It is known as a stump. So what happens is the bottom of the stack gets eroded, the stack falls into the sea, and there's a little stump. You may be able to see the stump at low tide, maybe, but sometimes not. Okay. Again, they're not all huge big features. This is a small little sea arch, all right, formed. This is just off Long Island. So again, you can see this is a smaller example, but would have formed in exactly the same way. And then the last bit for today, okay, is our honeycomb weathering. Now we started with a definition of this, and we're just going to finish it off. All right. There's some really good, I shouldn't have said diagrams, there's some really good photos on the next page that we'll finish with. All right. Excuse me. This is a general term given to the jagged or very sharp surface of the bare rock along the shore. Now again, if you've been to any family islands or even parts of Nassau, I'm sure you've accidentally stood or trod on some of this very sharp rock, and it's very painful. Okay. Now, the spiky rock is more likely to be fossilized plant roots. Okay, so this isn't as difficult as it sounds, but called rhizomorphs, from rhizo for root or rhizo, and morph for shape. Okay, so it's a root shape. So the sand dunes which eventually form the ridgelands. So remember, our ridgelands are formed from sand dunes which have hardened. Okay, so when these sand dunes form the ridges, they had various plants growing in between them, or the roots going through those sand dunes, which eventually hardened into rock. Okay, their roots secreted substances, all right, that hardened the soil or sediments around them. So again, this is a biological effect. All right, so the roots and the vegetation, that soil, would have, well, some of them excreted different chemicals that hardened the rock right around the root. Okay, when erosion takes place in the spray zone or in the tidal zone of the shore, the hardened rock of the rhizomorph stands out as spiky projections. All right, so they're very tiny little ridges and very hard pieces. Okay, let's have a look at the next page. So I'm not sure if any of you have ever seen some of this. I've certainly seen it in Eleuthera and Long Island. All right, so exposing the face of an eroding dune in Long Island. All right, so you can see it almost looks, well, it looks a little bit scary almost, but you can see some of the root patterns, especially here and here. Okay, the root is long dead, it's gone, but the hardened rock around it from that chemical mixture remains. Okay, and there's lots of little tiny holes and stuff in this, and it's extremely sharp. Another less extreme example here, okay, at New Providence. Okay, the honeycomb effect is caused by different erosion of the limestone rock and the numerous rhizomorphs it contains. All right, so again, you can see this very sharp, very uneven rock surface. Okay, looks a little bit like our limestone pavement from a previous topic, but it's extremely sharp. The last little bit down here, wave cut platforms, we've done that already. We don't need to review that. There's no assignment for today, okay, and that is erosional landscapes finished.